So today we're going to talk about AI's role in society. So this is going to be a bit of a departure from the rest of the class. So far, we've only focused on the technical aspects of AI. We talked about machine learning. We talked about state-based models with search, MDPs, and games. We talked about Bayesian networks. We talked about logic. And so now we're going to talk about societal implications. And so the first thing you might wonder is, why should we care about this, right? So this is a class it's a CS class about AI. So why are we talking about this in this class? And there are many other classes that you could take to learn much more about AI in society. So I'll try to argue why this is here today. So first is, indisputably, technology has massive impact on society. This has been historically true. You can go back as far as printing press and the steam engine and things like that. But more recently, internet, mobile phones, social networks have just changed the fabric of society, and for either better or in some case for worse. And AI in particular is the fastest growing in history. And part of that growth is due to the fact that we have internet and social media to overlay the growth of this technology on top of. For example, right now, ChatGPT has 800 million weekly active users. And this is going to keep on growing. So if you think about it, we're only in the very beginning stages of this technology, revolution. The second point is that we as technologists, speaking to an audience who is probably primarily computer science, we have incredible amount of power, right? First, we understand the capabilities and limitations of this technology better than anyone else. We can choose what problems to work on, and given those systems that we decide to build, we make design choices that shape access or how the system works. So, for example, you might, when building a model, you have to decide what languages do we support, or if you make a model, do we release the weights? What kind of request should your service take, and which ones should you refuse? So as you can tell, these are design decisions that no one else is going to make. It has to be the job of the model builder. And these are not technical questions. These are kind of design decisions that have, implications. So, if you're not convinced yet, you can maybe you might be wondering, well, we're just here to develop the technology. Let someone else worry about it. That's someone else's job to worry about the consequences. And just to hammer it home, this is like a relatively extreme example, but, there was this, a man by the name of Wernher von Braun, who in World War II, he helped Hitler develop rockets, and then he came to the US and helped develop the space program. And the song by Tom Lehrer kind of sums up his perspective. Once rockets are up, who cares where they come down? That's my department, says Wernher von Braun. So this is a bit kind of, it's a song, but I think it describes an attitude that we probably don't want to take. Okay, so let's say we do care about technological impact on society. What should we do next? So you can start with now, the principles. And the broadest principle is we want to ensure AI is developed to benefit and not harm society. It almost sounds like a platitude by now. And there are a number of documents you can turn to draw inspirations. For example, there's the Belmont Report, which talks about ethical principles for human subjects research. And this came about because there was this really unfortunate study that was done in 1974 where they basically gave a batch of African-American men who were known to have syphilis but didn't treat it because they wanted to study what happens if you don't treat syphilis. Apparently not great things. So that led to the creation of the Belmont Report to protect human subjects research. And the idea is that There's some principles here, respect for persons, which leads to the idea of informed consent. Subjects have to consent and understand what they're getting themselves into. We want to maximize the benefits and minimize the harms, and don't affect some groups disproportionately more than others. All of these things were kind of violated in this previous study. You can also look at things like the ACM Code of Ethics, which talks about we want to contribute to human well-being, avoid harm, and respect privacy and confidentiality, and so on and so forth. So these all seem pretty unobjectionable, right? But the real question is, how do we actually operationalize them in practice? Because it's all well and good to say we want to benefit society and minimize harm, but what does that actually mean? So I'm going to talk through a bit of, let's say, call them frameworks to think about and help us orient how we should think about this admittedly very challenging problem. So this is a question: how do we benefit a society by developing AI? And the main problem here is that we don't get to fully control its use, right? If you commit a bad act, you can then that's sort of your choice, and we can sort of say to ourselves, don't do bad things, but the challenge is that that's not our call. And AI is an example of a dual-use technology, one that can be used to both benefit or to harm people. And dual-use technologies aren't new to AI. They've been around for some time. I think they were this idea of dual use came up probably first when thinking about in the chemical industry, where ammonia was used heavily for agriculture, but then they could also be used for chemical weapons. Rockets, as we saw earlier, they can be used to fire missiles at people, or they can send people into space and discover science and all that. Nuclear is probably a prime example. They can be used to as weapons or for energy. Cybersecurity. If you have, let's say, an agent that can hack into a server, this can actually be useful for penetration testing, so testing your own servers before you deploy them, or they could actually be used for cyber attacks on someone else's servers. And then finally, encryption, so they can protect user privacy, and we all love and encryption is the foundation of how you can do anything on the internet these days. But it can also be used to conceal criminal activity. And encryption, we all take it for granted today, but 20, 30 years ago, there was a big debate over the dual use of encryption, and that actually was banned, or strong encryption was banned for a bit of time. So, and AI is a dual use technology. But that doesn't mean you just throw up your hands and say, well, it could go either way. It could be positive, negative. Let's just, you can't do anything about it. There are things you can do to steer AI so that it tilts towards the benefits. I said it was hard, but I didn't say it was impossible. So the way to think about the role of AI in impact on society is this diagram here. There's two axes here: intent and impact, right? And intent could be good and bad, and impact could be positive or negative. So in this upper left quadrant, you're trying to do good things and you have a positive impact. These are beneficial applications, to healthcare, education, science, things like that. Then you could be in this lower right quadrant where you have bad intent and you have a negative impact on society, spam, fraud, disinformation. This is generally about misuse of AI. So don't do that. The more subtle case is in this upper right quadrant where you have good intent, but somehow something happens and it turns out to have a negative impact. This is probably the more common case in a lot of situations, and that's something we'll talk about. And now, there is also this other quadrant here where you have bad intent and you end up having good outcomes. That, as far as I know, I don't know. I guess you have to be a pretty bad supervillain to kind of live in that quadrant. So benefits, beneficial applications. I think there's many things that we can do that helps the world. And remember, we as researchers, we choose what problems we work on, right? So we can choose problems along these lines that have a more direct impact. So, for example, just to name a few, AI will have a big influence in the biomedical space to accelerate drug development. For example, AlphaFold and its successors not only can predict protein structure, but also how these proteins bind to various kind of drugs. And this can be used to essentially accelerate drug development because you can do a bunch of simulations or model calls instead of actually doing the wet lab experiment. More on the clinical side, it could be used to help doctors, for example, answer questions on electronic healthcare records, or it could be used to communicate with patients directly. Let's say translating medical jargon into language that one can understand. In education, on the student side, you can have personalized learning. On the instructor side, you could design curriculums, create problems, automatic grade. The main challenge here is to think about pedagogy and rather than task completion, because if you have a tutor, you don't want it just to give you the answer immediately. You want it to make sure you understand. Robotics, there's self-driving cars, which are actually, pretty good these days. And it seems like people are now looking more aggressively at, other forms of robots, such as in the household, which would have significant implications for countries with large aging populations. Weather and climate for forecasting, for early warning and monitoring the effectiveness of various climate policies. So all these things are things that AI could have a very positive impact on. Then a few misuse. Obviously, there's more, but just to give you a sense, there's cyber attacks. So AI can be powerful enough. There's a recent Anthropic post showing that they detected a bunch of attackers using Claude Code to conduct a large-scale cyber attack. AI agents are getting good enough where these things can actually be quite effective. Now, remember, some of the flip side of this is that the same agents could be helpful for securing our system or detecting vulnerabilities. So AI is always dual use in this way. We can also generate text, images, audio, video now with stunning fidelity. And this obviously can be used for spreading disinformation, misinformation. This can be used by state actors, or it could be used by teenagers that want to do harm to their peers. These are kind of fairly big and serious problems. Then, if we think about accidents, so this is really about AI having unintended consequences. So neither the AI developer nor the users wants this to happen, but it happens anyway through essentially oversight or negligence. So there's inequality. So AI works better or worse for different groups. So if you have an accent, you might realize that voice assistant just may not recognize your speech as well as if, someone who doesn't have an accent. Sycophancy has been a big problem where it can affirm a false belief that a user has. But this is especially troubling for users with various mental health issues, which can lead to self-harm potentially. There's over-reliance, so just to back up a little bit. So sycophancy, right? Why is this an accident? So it's not the case that, language model providers wanted this to happen. They're fine-tuning their models so that is, pleasant for the user. But as a result, a side effect, you get some reinforcement of false beliefs. For over-reliance, again, the model developers want these models to be helpful, but if they're too helpful, then people might become over-dependent and lose ability to critically think for themselves. There's cultural homogenization, where AI reinforces existing biases and stereotypes, and AI displacing various job functions. So for example, entry-level software engineers are maybe at the level of what Claude Code can do, which can cause some stress in terms of how for hiring of those entry-level positions. So in summary, there's 3 categories. Benefits, we should do more of this. Misuse, we should implement safeguards to try to prevent. I don't think you can prevent misuse altogether, but you can try to prevent it. And accidents are probably where we can do the most, right? You can do much more preventative testing and just be careful before you deploy an AI system. Okay. So the other thing I want, another view of AI societal impact is, thinking about the whole ecosystem. And this is something that Rishi will talk about on the next lecture. And the starting point is that we often think about an AI model, right? We think about a model and its properties. Does it generate the correct answer? What kind of queries does it handle, and so on? But that's really insufficient. I think we need to really take an ecosystem view on AI to understand how AI impacts society. So here's a picture you should have in your head, right? So here's your AI system. And it interacts the world through either upstream or downstream. So in the case of, let's say, a large language model, it interacts with upstream in that it takes, data which are created by people. It takes GPUs, which comes from resources and energy in the environment. And an AI system is built and is deployed downstream to users. And the use and misuse of that AI causes various impacts on people. So AI, people kind of live on both sides of this picture here. So let's look at kind of upstream. So we know AI models, especially large language models, are created from data and compute, right? Data, it's important to remember that they come from people, right? This idea of, from a model developer's perspective, you can have this view that, well, the internet data is free. It's just out there and I can crawl it. But all that data is really the product of people's labor. And that's something important to remember. And compute, it all comes from, extracting resources from the environment, whether that be energy or, materials to build the actual data centers and the GPUs and so on. There's a few considerations that are present upstream. So you think about privacy, where people's information is unintentionally revealed. Copyright, which I'll talk about a little bit later, where creators might not be appropriately compensated. So an incentive system is kind of broken. Labor practices, where workers might be treated poorly because AI models are fairly data hungry, and you have to usually pay people to create data for you. And if our environmental impact, now that some of these AI data center builds are kind of insane in scale. This is, think about carbon emissions, water usage, and resource extraction. Downstream, AI is used by people, and this could have positive and negative implications. So inequality. So AI helps some more than others. It can generate toxic content or take harmful actions. We already talked about over-reliance and jobs. Okay, so now in the rest of the lecture, I want to deep dive a bit into a few topics. It is impossible to cover the whole breadth of what it means for AI to have an impact on society, so I'll try to cover a few representative samples to give you an idea of some of these concerns. So let's talk about inequality. So in 2018, there was a very classic study done to show what inequality means for AI. So this was the Gender Shades Project. They evaluated gender classifiers on from Microsoft, Face++, and IBM on a population. And then they stratify based on demographic group. So darker male, darker female, lighter female, and looked at the accuracy rates. And what they noticed is that, there's one group that had much lower accuracy than the other groups. So if you were just measuring average accuracy, you would think that these systems work pretty well. But we would notice oversight that there was actually an intersectional group here that was getting much worse service. So one interesting thing is that the study came out, and then after the study, the systems got fixed. So one thing that's, I think, a big takeaway here is that this shows the power of third-party auditing, which can be a powerful incentive to get companies to actually fix problems. And the first step actually in solving a problem is to identify the problem. Sounds obvious, but I think this really, you have to actually do it to really see its impact. On the technical side, how do you reduce inequality? Well, one thing you could do is collect more data for underrepresented demographic groups. This generally can be costly, which is why I think a lot of companies might not have the data to in the first place. You can also do some things on the algorithmic side where you can upweight represented groups in your data set. You can use a tool called distributional robust optimization, which looks at not just the average accuracy, but the worst case accuracy over groups. So what you would do is you would maximize the minimum accuracy over all these groups, and that objective function would allow you to make sure that all the groups have good accuracy. Now, just as an aside, one thing you might wonder is gender classification even well-defined task given because it's ultimately based on an image. You're relying on superficial features as opposed to reaching the kind of gender as a self-identification. Another type of inequality comes more at sort of a global level. So I think we tend to think a lot about models and what's happening in the US. But if you look so here's a study that was done where they took this model that was fine-tuned from Llama, and which was advertised as a reward model, which it scores basically how good AI assistant generations given user generations. And they evaluated based on using this reward model, different generations to where you're from, I am from, country. And this reward model is usually used to then post-train a language model using reinforcement learning, as we alluded to, Ken talked about last time. And we see that this is very uneven, right? So higher is blue is better, red is worse here. And maybe not surprisingly, like US and Canada have really high reward, and places like Saudi Arabia have very low reward. right? So for no particularly good, reason, obviously this is not a particularly fair reward model to use. And you can imagine if you fine tune on this reward model, you're going to get some pretty serious biases. Another type of inequality that happens is a bit more subtle. This has to do with spurious correlation. So here's an example problem from a few years ago. So the task here is given an image of an X-ray. Try to predict whether there's a collapsed lung or not. So this is some bad medical condition. And if you look at the accuracies here of the system, it's not bad. But if you take a closer look at this image, this is classified as a collapsed lung, and the researchers noticed that see this pipe here? This is called a chest drain, which is a common treatment for a collapsed lung. And what happened was that the model was basically trying to leverage the presence of a chest drain to predict whether it had a collapsed lung or not. So this is bad because if you look at, this is the accuracy, so higher is better here. If you look on average, that's the blue, so it's 0.87. If you look at the people with chest drains, so these are the people who got treated for collapsed lung, it looks great. But the people who haven't gotten treated for chest drains, it's much worse, right? Which means that the people who don't have chest drains, which means that they actually haven't been treated, but nonetheless need to be treated, we're not able to actually predict those on those folks very well, which is bad. So this is known as a spurious correlation. These are patterns in training data that don't generalize. All machine learning algorithms do is they look for patterns in data, right? And they look for patterns or correlations. And a spurious correlation is one that you see in the training data and the learning algorithm says, aha, this is how I'm going to predict collapsed lung or not. But it actually turns out not to be the right causal variable to latch onto. And therefore, if you have another condition, it won't work. And this affects minority populations often the most. And the takeaway from all of this is that it is really important to not just look at one number. You look at accuracy and you get it up to 90% and you say, wow, I've made so much progress. It is really important to monitor metrics on different populations just to make sure that you're not essentially harming a particular subpopulation. Okay, so next I want to talk about alignment. And alignment is about how do we make an AI system do what we want to do. So it sounds, fairly straightforward, but it turns out not to be really. So here, if you put on your reinforcement learning hat, what you would do is you define a reward function that captures the values or what you want. And then you train an agent to maximize the expected reward. Okay, so what could go wrong here? Any ideas? You just write down what you want. That reward function is very hard to define, and especially in all cases. And what happens if you don't get it right? You get reward hacking. So this is an example from old OpenAI blog posts before they started training language models. And this is a game called Coast Runners, where the goal is to race a boat and to finish a race. And the reward that you have in this game is that you're getting points, and you get points for hitting things. So when you do reinforcement learning in this environment, the agent learns this behavior where the boat is just swinging around and just hitting this boat many, many times and not completing the race at all. Right? So this is an instance of reward hacking, which is where the reward function doesn't capture what we want. And this is terribly frustrating for a model developer because they're thinking, just do what I mean, not what I say. But alas, the algorithms can only do what you say. So this shows up in more realistic cases. So for example, we have a lot of people interested in building coding models. And a natural reward function for a coding agent is that you write code that passes unit tests. But we know that tests are always complete in their coverage, which means that just because you pass the test doesn't mean you actually get the answer that your code is, correct. But even if your code is correct, it might have other problems. For example, it might not be secure. It might not be robust to, adversarial, testing. And there's this work that evaluates language models both on correctness and secureness. And even if it were both correct and secure, it might have other things. For example, it might have bad style, it might be complex, and so on. And it's really, really hard to get this reward function right. So, and what happens if you don't get the reward function right? You should be cautious. Never over-optimize your reward function. That's incorrect. If it's slightly incorrect, you can optimize it a bit. And likely you're going to be moving roughly in the right direction. But if you over-optimize, you're going to start gaming the reward function and finding all sorts of devious ways to squeak out more reward. And this is generally true, I think, in life. So a second problem is the idea that if you think about the reward function representing values, the question is, whose values are we talking about? And there's this idea of pluralism, which means that, different people have different values, right? So there's actually no one reward function that works for everyone. For example, the view of is it okay for governments to moderate public social media content? People that are divisive, on this. And so, it's sort of, dangerous to pick one view of this and just fine-tune your language model to, only that view and serve it to the world, because then you're projecting that view on everyone. And so ideally, models would represent the diversity of thought. Of course, within the Overton window, you don't want to represent maybe like fringe kind of ideas. At the same time, models should be personalized, but not so much. We don't want everyone living in their own echo chamber. And certainly, we already saw that sycophantic language models are a bit dangerous. So then there's this kind of trade-off between how much do you represent the diversity of thought versus personalized to an individual user. So again, there's no kind of right answer or recipe here. The third challenge has to do with scalable oversight. So language models are getting really, really good. They can solve incredibly complex problems. And already they're generating solutions that are hard for experts, to verify. So we had this paper on unanswered, questions where you take a look at all the unanswered questions on, Stack Exchange, and we have language models that generate the answers, but it's hard to actually verify whether these answers are correct or not. So there's a few ideas around scalable oversight. One is that you can break down a problem into smaller, problems, so that humans might be able to verify individual problems. You can use AI itself, because if AI is better than humans, at least on some tasks, maybe you can get a second AI that's better than human to keep the first AI check. There's some ideas around debate and constitutional AI that are proposing that really the only way to address this is to kind of use AI to monitor AI, which obviously has some kind of recursive problems. Another thought is that if you have process level supervision or evaluation, which means that language model generates a rationale and then you check the steps. Basically, the language model shows the work and then you're checking the steps. That is generally going to be much more effective than looking at just did you get the answer right or not. There's some other things you might imagine, for example, formal verification. If you can cast things in terms of theorem, proving, then you're good. But most problems in the world are subtle and complex, and you can't really do that. So, summary of all the things that can go wrong here. The reward function isn't what we want exactly, leading to reward hacking. There's actually no one reward function in the first place, so you have to think more pluralistically. And it's really hard to, even for humans, to write down a reward function in the first place, or to provide feedback to an agent, let alone write down the reward function. So you need to have some story for scalable oversight. Okay, so moving on, to copyright. So copyright has to do with the upstream dependencies on the language model, in particular, data. So currently, there's a lot of lawsuits floating around in the Gen AI space, mostly around copyright. And recently, there was a settlement. Anthropic agreed to pay authors $1.5 billion to settle a copyright lawsuit. And so this is, pretty meaningful that, this is a big issue. So I want to take a step back and think about how to think about, copyright. And so this will be a bit, going through kind of basic kind of IP law. But I think it's important for understanding kind of where language models fit into the space. So why does copyright exist? So copyright is part of a framework, intellectual property law generally. And the goal is to incentivize creation of intellectual goods, right? And the idea is that you protect creators. By protecting creators, you incentivize people to be creators. So there's many types of intellectual property, copyright, patents, trademarks, trade secrets, but the most relevant for foundation model training is copyright. So this actually goes back all the way to 1700s in England. This was the first time that copyright kind of emerged. In the US, more recently, there was a Copyright Act of 1976. And it basically says it applies to original works of authorship fixed in any tangible medium of expression, and so on and so forth. So in particular, it applies to original works. So collections are not copyrightable. So like you can't copyright a telephone directory because it's just like a collection of numbers, unless there is some creativity in the selection or arrangement. So if you just list everyone alphabetically, there's no creativity, but if you have some artistic way of doing it, perhaps that could be copyrightable. And in particular, applies to expression, not ideas. So you can't copyright the quicksort algorithm, for example, but you can copyright the code that implements the quicksort algorithm. So in 1976, the copyright got expanded. So before, things that had to be published to get copyrighted. And after 1976, all they had to be was fixed. So you don't have to register a copyright for it to to be copyrighted. This is in contrast with patents. If you invent something and you don't patent it, then someone can just take it and run with it. But so the threshold for copyright is extremely low. So this is something I think a lot of people don't get, is that it's not just that books are copyrighted, but your website, if you have a website, is copyrighted. Like your technically, I guess your homework in 221 is copyrighted. It's your work. Any essay you write is your work. And so it's extremely low, right? So then you might wonder, then if that means basically everything is copyrighted, and you wouldn't be wrong. But there's more to the story. So registration is required before the creator can sue someone. So if you didn't register, you have a copyright, but you can't go and sue someone for copyright infringement. It's pretty easy to register. You pay $65. But also copyright expires. It lasts for 75 years, and then it becomes part of what is known as the public domain. So works of Shakespeare, Beethoven, all the works in Project Gutenberg, all the old books essentially are in the public domain, which means that you can use them. There's no problem. So summary is that most things on the internet are actually copyrighted. Okay, so then the question is like, well, if it's copyrighted, how can you use a copyrighted work? There's two ways. You can get a license for it, or you can appeal to the fair use clause. So a license is basically a contract that says, that is granted by a licensor to a licensee and effectively says, you can use this and work that I own, and I promise to not sue you for using it. So there's something important called a Creative Commons license, and this enables free distribution of copyright work. So if if I create some work and I put a Creative Commons license on it, that means people can use it freely without, I basically give permission for anyone in the world to use it. So examples are Wikipedia, Khan Academy is Creative Commons, Free Music Archive, a bunch of things are Creative Commons. And this was created in 2001 to essentially bridge public domain and existing copyright. So it basically allows creators to explicitly say, effectively, this is public domain, even though 75 years hasn't elapsed. But most model developers, in addition to using public domain data, they also license data for training foundation models. For example, Google uses, these are some examples. So Google pays Reddit for their data, OpenAI pays Stack Exchange and Shutterstock, and otherwise they wouldn't be able to use that data. Okay, so if you think about it, licenses don't cover that much, right? So you have to pay for data. It can be Creative Commons, or it can be in the public domain. But the vast majority of data on the internet is none of these. And that comprises most of the training data for language models. So then what you have to do is appeal to fair use, so Section 107 of the Copyright Act. And it basically gives you, fair use says there's 4 criteria to determine whether you can use a particular work. And it depends, whether you can use it depends on the purpose of the use. So if you're using it for educational purposes, that's going to be more likely to be fair use than if you're trying to make money off of it. If you're taking the work and doing some transformation on it, it's going to be more likely fair use than if you're just taking it and reproducing it and reselling it. It also depends on the nature of the work. If it's factual, then it's more likely to be fair use than if it's fictional, because facts are closer to things that aren't really about creativity. It's just like what exists. And the more non-creative something is, the more fair use it is. So, and then also it depends on how much of the work you use. If you use a snippet, it's fine. If you use a whole book, that might be problematic. And then finally, this is a kind of an economic condition. It depends on the effect of the use on the market, right? So if you use someone else's work and you end up competing with them or that entering the same market, that's going to be looked down upon, as opposed to if you're using that work and doing something completely different. So here's some examples of fair use. You watch a movie and you write a summary of it. That's totally fine. You re-implement an algorithm, which is idea rather than copying the code. So remember, expression is copyrightable, ideas are not. And then Google Books, indexing a bunch of books and showing snippets. This is fair use. It took a very, very long lawsuit to conclude that it was fair use, and now it sets a lot of the kind of precedent going forward for data use, but now it is fair use. It wasn't, clear at the time. One thing also to note is that copyright is not about verbatim memorization. You can copyright plots and characters like Harry Potter. So even if you're not writing, you're not like copying the book, Harry Potter book, but if you use the characters, then that could be a copyright violation. But if you are parodying, then that's more likely to be fair use. So there's a lot of kind of semantic subtleties around fair use. It's about semantics and economics as opposed to purely technical notion of string overlap. Okay, so now for AI models, what is the implication? So first of all, copying the data first of training is already potentially a violation, even if you don't do anything with it. So even if you don't train a model, if you just by copying it, I mean, that's why it's called copyright, you could potentially violate unless you appeal to fair use. Now, it has been well argued, I think, that training ML models is transformative, right? You're not just like taking a book and then, putting it up on your website for anyone to download it. The book is trained. Clearly, the model can do things that the book didn't. So it's a transformative, operation. And furthermore, you can argue that ML systems are interested in the idea. So for example, you might want to classify stop signs versus not stop signs. The ML system couldn't care about what exactly your stop sign image looks like. It just wants the general idea. So it's not really interested in the artistic choices. Now, that's for classifiers, so it depends on which ML system you're talking about. And then there is a kind of market issue where foundation models can and do affect the market. So there's a reason why writers and artists have a lot of angst about AI, because their livelihoods sort of are impacted by the flood of kind of AI-generated content. So, but this is also regardless of copyright. So even if AI were able to, if AI, let's say, were not trained on any of this data, but still were able to generate things that were really competing with the artists, there would still be a problem, but it wouldn't be a copyright issue. Okay. So the final piece is that even if you have a license or you can appeal to fair use for a work, there could be terms of service that prevent you from actually using it. So for example, YouTube actually has a lot of Creative Commons content on it, but its terms of service prohibits technically downloading, videos, and, at scale and storing them. So you can run into barriers even if you have, you're free on the copyright side. Okay, so, now I want to talk about one kind of subtlety here, right? Because I talked about how an ML model trained on data is transformative. And it's true that a model is different than the data, and it can do things that the data can't do. It can answer new questions, it can generate new sentences. But there is a sense, and people have studied this extensively, that the model can memorize the data, and thereby copying the data. So for example, the idea of memorization is the text sort of contained in the model weights? Now, what does that mean? You can operationalize that by looking at the probabilistic model. So you take a book and you look at the probability of a token I of a book given the previous tokens, and you look at how high that probability is. If the probability is very high, that means essentially the model knows the book, and therefore the book has been memorized and has been copied into the model. Now, if you do this on a few models, like Llama 370B, you actually notice that some books, like Harry Potter, are actually memorized very heavily. So this shows for 3 different books, and the rows are different models. Each of these bars shows the extent to memorize. These models are memorized. So this book, there's all this white means that there's very little memorization. Whereas down here, it says that Llama 3.170B has memorized Harry Potter and Sorcerer's Stone basically kind of extensively. So this is interesting from a copyright perspective, because a lot of the arguments around training is fair use, it's fine because we don't really we're transforming the data. This result kind of calls that into question because, at least for some books, the models are copying the data. There's another level here, though, right? Just because the model assigns high probability to tokens doesn't mean that it's a user can leverage this fact to cause harm, right? Because ultimately, copyright is trying to protect creators. And if some third party can't, let's say, get the book out of the model, then in some sense the harm is limited. Now, so extraction is the idea that a lay user, let's say, without too much work, can actually extract the text from model weights. And there's an experiment where if you prompt Llama 3.170B with just the string Mr. and Mrs. D. So those of you who have read Harry Potter know that this is basically the first few words of Harry Potter. And you put that into a language model, this Llama 3.170B, and it will generate all the rest of the book. And by rest of the book, I mean 460,000 tokens. Almost verbatim, not quite verbatim. And so this is additional evidence that, well, this could be problematic because that if a user is able to download these models, which are free, you can download from Hugging Face, and then just generate any book out, then that is basically like putting the books out for anyone to download, which obviously violates copyright. So extraction in general is a stronger case for infringement. Now, fortunately, it turns out that this is the exception rather than the rule. So for some reason, Llama really likes Harry Potter, but for example, M Butterfly, you can't extract anything out. So I think this complicates this, the copyright story a bit because it really depends on the model and it depends on the work of art. So you can't say universally models memorize works, nor can you say they don't. It really depends. Okay, so there's a few other links here which you can read if you're interested. So now the final thing I want to talk about is the idea of openness and transparency. And with this, I urge everyone to think about not just what a model can do, but essentially how a model is built. So sort of the meta stuff, right? So in particular, who can make decisions about a model's behavior? Who can even build a model, at all? And there is one kind of risk that I haven't mentioned before, which is centralization of power. Right now, there are very few big tech companies that can build, frontier models because these are very capital-intensive projects, and there's not that many people who can do it. And furthermore, very little is revealed about how they work. Now, a lot of the discussion about AI risk and benefits and safety are really tied to what these models do and how they impact the world. But I think it's important to realize that a lot of what they do is governed by the processes by which these models are built. So let's talk about kind of transparency a bit. So transparency is, think about it as a prerequisite, right? So along the lines of, if you can't measure it, you can't improve it. So suppose we want to make AI systems safer, harm people less, and so on. If you don't have the transparency of how these models are built and what they can do, you can't even begin to start making these models better. So we had a project called the Foundation Models Transparency Index, which is one take on how to improve transparency. And the idea is that it evaluates model developers based on their transparency practices, right? So this idea of an index, it's commonly used in economics. For example, the Human Development Index monitors basically certain types of indicators that have to do with how the society as a whole is doing. So there's 100 indicators that capture the upstream, the model, and downstream properties. Okay, so this shows the upstream indicators include information about the data, how the data was created through labor, compute, and then there's things about the model, capabilities and risks, and what mitigations were done, how the model was, and then there's downstream indicators on how the model is distributed, who can use the model, what they can use it for, if there's a problem, how you provide feedback, and so on and so forth. And those are the rows, and then the columns are different models. So we have Anthropic Claude 3 here. This is from 2024. And each cell basically is a score. So, blue is great. Red is not great. And you can see that the transparency levels of different companies is fairly uneven. So there's some that do quite well, 100%. Whereas some of the closed models, they're very poor, especially on some of these upstream metrics, because there's not much disclosed about how these models are built. And remember that in order to mitigate some of the, let's say, the harms around labor practices or environmental impact and understanding copyright infringement, we need to know at least the very minimum what data and the compute situation for building various models are. So here's just a kind of a summary statistic of how the various model providers are doing. And now the idea of the theory of change, so to speak, is that public reporting will incentivize companies to be more transparent. So remember the Gender Shades project. By just simply reporting the status quo, that there were these disparities, led to improvements. And with this project, there is something similar that happened, where if you look at the transparency in May 2024, it has gone up by and large from October 2023. So this is an example of how just by measuring, you can sort of get people to pay attention and therefore incentivize improvement. Okay, so related to transparency, but not identical to transparency, is the idea of openness. And so this is a topic I actually care quite a bit about. So the idea is these foundation models are built, and the question is how open are they? So openness is a spectrum here. So on one end of the spectrum are closed models. These are models like GPT-5 or Claude, where you can only use them through API access or through the product. You can't access the internals. Then there's open weight models such as Llama, DeepSeek, Qwen, and so on, where the weights are released, but you don't have the data, you don't have the code, you don't really know necessarily how the model was built. And then you have open source models where you have the weights, you can see the code and the data recipe, but still the development of the model is closed. And then finally we have open development where you basically see everything. And more importantly, you can have the community come in and contribute and audit and so on. And if you think about the relationship to open source software, where it's clear that open source software has been very successful for not just bringing in the community to further improve, has been better for security and decentralizing power. Imagine if back in the 90s, if Microsoft Windows had been the only operating system as opposed to Linux and the number of Linux-like operating systems that have existed. So one note is that often people say open models and they mean open weight models. Most of the models I think that people use are closed and open weight. But I think it is important to look at the whole spectrum here. And in particular, open weight models, even just because you're open weight doesn't mean you do well on the transparency index, because you're not talking about you don't have to say anything about your data to have an open weight model. But as remember, we need disclosures on the data to understand, things like copyright and, privacy, implications and so on. One thing, the way to think about open weight models is that they're essentially like releasing a binary executable. Right? You don't have the code. You just have something that you can run. And from that angle, it's clear that, having just a binary executable that you can run on your computer doesn't constitute open source. Okay. So, why is openness, important? So this paper talks mostly about kind of open weight models, but some of these ideas can be extended to the full spectrum as well. So first, the benefits, right? So increased innovation and customizability for researchers and developers, right? If you only have an API access, then there's only so much you can do. You can do only what the API allows you to do, which is put in a prompt, get a response out, right? So you can't, innovate. With open weight models, you have the weights, you can fine tune, you can take layers. So people do various things like take the layers and quantize and customize the models in all sorts of creative ways, which is something you can't do if you have an API-only model. Openness is also important for increasing transparency, though, as I mentioned before, it's just having the weights open is not enough. There are actually many providers that, if you look at Mistral, 7B is an open weight model, but they're actually, not. There's only 55 out of 100 on the scale. And finally, openness hopes to reduce the centralization of power. And this is because you have this artifact in the world, and people can take that and customize it however they want, as opposed to having a central source of authority to dictate how model behavior should be for everyone. So now, that said, some of this is also partial, because at the end of the day, it still requires a huge amount of capital to train a model. So it's not like once you have open weights, everyone can train their own foundation model. So the other thing to think about is the risks. And mostly the risks around open models have to do with misuse. And this is because anyone can take an open weight model even it has been, safety tuned, it's fairly easy to just strip off the safety, and you can use it to generate disinformation. You can use it to to hack into systems potentially. One thing that I think is important is to think more about the risks in terms of the delta from what exists already. So this is called marginal risk, right? So in an alternative world without the open release model, you still have closed models and you still have the internet, right? As you can see that, Claude Code example where hackers were actually using Claude Code to do cybersecurity attacks. So it's not that there's no harm from closed models either. And furthermore, a lot of the information about how to make, bioweapons is actually just on the internet. It's a lot of, and there's, classes that talk about, if you take an advanced bio class, then you probably learn a lot about how to do it as well. So I think that's something that's important to take into account. It's not saying that there's no risk, but that there's the relevant quantity is the marginal risk. And then the second point is that it is important to think about the whole ecosystem of how the impact happens. So just thinking about one example that people are worried about is people take, a layperson takes a open weight model, they ask it to strip off the safety, and now they can prompt it to get it to help you make a bioweapon. And one thing is that the language model only helps you with designing it, right? You still have to go manufacture it, you still have to deploy it, and those are additional gates that actually have a bunch of weaknesses that could be shored up. And one can make an argument that sometimes gating at the kind of the physical level is easier than trying to do at the model level. But the reason this paper exists is that in 2023, in particular, was a year where there was a lot of angst about AI, especially in the policy world. This is right after ChatGPT came out, December 2022, and then everyone, kind of the world woke up, and there was a lot of confusion about the risks and the benefits, and there was a lot of debate over should we have these open weight models at all? Meta at that time was putting out open weight models, and I think this framework allows us to lend some clarity into how to think about the benefits and the risks. Okay, so to summarize, hopefully I've convinced you that technologies should care about societal impact. After all, we are people, and and as people, we should care about the world that we inhabit. But it's hard. AI is dual use. There's a lot of uncertainty, especially since AI is growing in capabilities so quickly, which makes it hard to reason about what the exact impact will be. That doesn't mean we don't try. I think we can do a lot of things here. I think we talked about how you can focus on beneficial applications. You can try to deter misuse, and you can try to prevent accidents from happening. Hopefully, we've talked through some examples, so at least you have the language and awareness of some of the issues that come up. I think one general comment is that we need to think about the whole ecosystem, not the model. So as technologists, we often fixated on, okay, the data shows up at the front door. We figure out what the algorithm is, how you train it, how you evaluate it, and then that's it, right? But I think in order to meaningfully talk about societal impact, you really have to understand both ends of both input upstream and output downstream. When we talked about inequality, that motivated me to monitor multiple metrics. Same with alignment. because of reward hacking, there's no one metric that is the perfect metric. There might not be even one voice here. And as humans, we might be not kind of powerful enough to even write down what the right thing is. That suggests a greater need to kind of have a much more comprehensive suite of metrics to monitor, because that is what will give us kind of robustness and an understanding of what our systems are doing. And then argue that openness and transparency is a basic, foundation. Think about kind of, kind of freedom in a kind of a political system. I think of that as kind of analog here. It's like, without it, I think it's very hard to make some of these basic, improvements. And then finally, the idea of auditing as a powerful tool. So on a technical level, it's just evaluation, right? It's just prompting a model with some things and you get out some other things, or, evaluation. But really, I think from a kind of a social perspective, it's auditing. It's raising awareness of certain issues that happen in the world, and that instigates the desire and hopefully the will to actually address some of these issues. Okay, so that is all for today. Next time, we'll take a deeper look at the players in the AI ecosystem. So Rishi is going to give a guest lecture on AI supply chains, which expands on this idea of paying attention to the entire ecosystem rather than the individual model. Hopefully that will give you even a greater appreciation for how to think about AI's role in society.